Greetings. This is Dr. N.K. Sakthivel. I periodically launching various videos on the subject fundamentals of data science, which is for BTech artificial intelligence and data science students. This subject is coming under 2017 regulation of our Anna University. So in this video, I would like to focus the importance of regression, least squares regression line, estimation, squared correlation coefficient, and how these technologies helping for predicting the highest accuracy, predicting content, predicting what is called the objectives of the data with the highest accuracy. The prediction accuracy is a very, very important one. So this is our idea. So first I would like to speak about this fourth unit content, because in this unit, so I would like to focus regression. So the regression line, least squares regression line, standard error of estimate, and interpretation of R squared. This is R squared. This is called squared correlation coefficient. R squared is squared correlation coefficient and multiple regression equation. Multiple regression is for getting highest accuracy. That means towards a polynomial equation, you know very well. And okay, that is a regression towards the mean also for minimizing a error. Okay. So in this topic, I would like to focus the three important topics and the problems. This is very, very important for as far as university examination is concerned. And not only that, as a engineering graduates wanted to understand this concept, these three concepts, especially the least square regression line, and okay, that is how to calculate standard error of estimations, and as well as okay, this is very important for error estimation. So this concept is very important one. The students can understand the concept and apply this with any tool. Preferably I am focusing Python, Jupyter notebook. With this we will discuss. So three topics are very important one. I would like to focus one by one. Before starting this, I would like to give you a small introduction that is called regression. So regression analysis. As you know, the regression analysis is a set of statistical methods, that is a mathematical methods. The primary objective is used to understand the correlation between variables. For example, consider, so we have a x variable, and with respect to x variable, what is association with y? For example, x value is increasing, and what will happen for y? So like this, so we can correlate with one or more variables. So that is a very, very important one. So that means, so the dependent variables versus independent variables association we would like to discuss. That is called regression analysis. So if we have that is a one variable, from that variable we can predict that is a value of other variable. So that association we can predict. So for that purpose we use regression analysis. So that very important purpose is the regression methodology is used to predict missing values or unavailable numerical data values from the data set. So very, very important for the research purpose. So regression means that we can correlate the two variables, that is one dependent variable and the second one is independent variables. If okay, that is a independent variable we are increasing, we are changing, what will happen to different variables? The independent variable may be a one variable or more than one variables. So if it is a one variable, then it is called linear regression. And if it is a more than one, what is called independent variables, based on that, if you are predicting the dependent variable, then it is called multiple linear regression. And non-linear is called polynomial equations, you know very well. So this is the primary objective. And then the regression line is a very, very important one. For example, I would like to show the diagram. carefully you see, so different data, what is called dots, or the data representation. Each what is called this notation represent a data corresponding to x-axis and the y-axis. So the one table, that is a one input, the second input, third input, and like this tens of inputs and all there. Then after that I wanted to make a line that is called a coefficient line, that is called the regression line. So this line is used to predict, that is unknown data, or it is used to predict a missing data which is not available. For example, from the diagram you can understand that. So that is, I am drawing a line, and here I didn't have any data, but this is the actual data. It is a predicted data. If I am taking a one value, for example here that is 1.5 and a corresponding, for example 2.1, let us consider, okay, or that is 1.9. So this is a new data, this is a new data. So from this known data, so we are drawing this line. How it is possible to draw? Okay, so I am considering what is called all these values, and okay, I am applying what is called least square mathematical model, and based on that I am drawing this line. So this line is called as best fit. For example, this line I can draw this like this also, this line I can draw like this also, but this line indicates that this line represents the meaning of entire data set, and it is the best fit. That means this line I have drawn, it gives the excellent prediction with the minimum prediction error. So that is very important one. So that is called regression line. And okay, so before that is a focusing a regression concept, I told you what is called a linear regression. So this is called a linear regression formula. Okay, so here, okay, so this is what is called, this x1 is called independent variable, and whereas this y is called dependent variable. So y equal to b0 plus b1 x1. So x1 is an independent variable and y is a dependent variable, and this is the constant, and b1 is the slope, or it is also called as what is called coefficient, first coefficient. If it is a linear regression, so we have only one coefficient, and if it is a multiple regression, so there are, that is a multiple coefficient. This is a b1, b2, b3, and like this. All these values, okay, I am calculating. Based on this, okay, I can predict what is called y. So the dependent variable y, okay, it depends on, okay, that is x1, x2, xn, as well as b1, b2, bn, and it's a coefficient. So like this you can understand. So this equation you can understand is a polynomial equation, or it is called non-linear regression equation. So now you can understand, okay, what is a regression. Regression is used to predict the unknown value. Regression is used to predict the missing value. Regression is used to predict unavailable value, that is called that empty where I can predict. So that for that purpose, so we can use regression analysis. So you can understand very well. So we will discuss with some suitable examples. So this is the basic concepts of what is called regression analysis. And here the placement of line is very, very important. Already I told you, this line I drawn based on all the inputs of these lines based on linear mathematical model, and this line represent entire data's input. It seems what is called calculating mean. That's not a mean, just for understanding purpose I tell you. So the placement is very important one. So the placement, the purpose is, if it is a best placement, that is called best fit, that is called prediction with minimum error. Definitely error will come, because during a prediction error bound to happen, but the error should be minimized. That is the reason why the placement of line is very, very important one. Okay, so with this idea I would like to give, that is additional input. For example, see here the placement of line. According to this example you can see, so we have, that is 5 data sets, 1, 2, 3, 4, 5. 5 inputs and all there. In my data set, 5 inputs. So corresponding x-axis as well as y-axis. Then after that, I wanted to make a straight line. That is called regression line. The regression line wanted to draw by considering all the data points. That means all the data points I wanted to join to draw this line. At the same time, I cannot draw. Reason because it's cannot touch all the points. Reason because it is a straight line. So at that time, okay, I wanted to consider these points. Okay, it is like a mean I told you. Okay, that is I am taking average, not taking average. Least square equation is there. I am applying that least square equation and calculating is a new point here. Okay, that is unknown point I find out. Then after that, this point I consider, okay, and this point consider, this point, okay, I consider, and according to this diagram, okay, this point, and okay, considering this also, and then drawing line. So this is the example. So my purpose is all the points I wanted to represent. So for touching this, all the 3 points, you can draw the line. Or okay, that is here also I can draw. Idea is 5 points. So if I wanted highest accuracy, maximum points I wanted to touch, that input is very important one. Okay, so according to that I can place the line so that the prediction error will be minimized. Okay, for example, this is the data I am drawing here. This is the data I am drawing here. So here there is a error. Okay, see, you can understand this is the error. Isn't it? It is a predictive error. But however, okay, to achieve the highest prediction, okay, I wanted to take what is called the mean and okay, I am plotting what is a new data. Okay, so that is the predicted data because I didn't have any data. I find out the data and the plot, okay, I drawn. So this and all predicted data. This is the predicted data. This is the predicted data. Predicted data, and this is the predicted data. Okay, and the dark circle is the known data. Okay, so from the known data I predicted a new data and drawn a straight line so that I can predict the future. What I can predict the future? For example, in this 20, okay, for that is x, okay, the cards sent, okay, 20. If 20 cards sent, okay, how much cards received? Okay, so okay, this is imagine that the line is drawn. So this line will touch here. Okay, corresponding y-axis I am taking. So this is the predicted data. So this is the independent data. So from the independent, okay, the dependent value I can be calculated. So this is the basic introduction about regression. Okay, now you can understand. Based on that, I would like to focus what is least squares regression. Least squares regression means, from the name it is clear that least means okay, minimum error. That minimum error distance I am squared so that error can be minimized, either plus or minus. You can understand this diagram. See here, okay, this is okay, that is this error, okay, is squared, then it is called the least square. Why it is called least square? Because this is the error, but the error is minimized. Okay, according to that I predicted a new point. So that concept is called least square. Lot of input I wanted to give, but for understanding purpose I am not giving much introduction on this topic. Okay, least square regression I told you. What is a mathematical model? So this is a mathematical model I already told you. Okay, that is A is the constant and B, okay, that is a slope, okay, or the coefficient, and X is the independent variable. And if I know this constant and this slope, that is called the coefficient, and the X value, and I can calculate Y value. Here Y is the dependent value. Why it is called a dependent value? So Y is always depends on X. That's a very important one. Okay, this is called least square. Okay, how to calculate A and how to calculate B? Okay, this is the equation. So for example, what is A? Okay, that is A equal to, so that is Y. Y, what is called head? This is called mean. Okay, Y mean minus B into X mean. So we know what is B. Okay, or B can be calculated here. Okay, R is equal to coefficient and after that sy means okay, sum of squares of y. This is a sum of squares of x. What is x, y, and you can I will show this table so that you can understand. See here, okay, this is the table. Okay, so this is the table. You can see, for example, I have x data, then after that I have y data, then after that okay, I can calculate xy, and I can calculate x squares and calculate y squares. So for example, see here, okay, sum of squares of y, okay, sum of squares of y. So y, so I calculated y squared here, okay, second y squared value, third y square. After calculating squares, I calculate a sum. So this is called y, okay, sum of squares of y. So this value will come after filling this value in this table. We will get a one value. This is called SSY. That means sum of squares of y. Similarly, what is sum of squares of x? So that is x I have. From that, okay, I can calculate x squared, x squared, x squared, x squared, and like this. So this is called sum of squares of x. Okay, now okay, you know very well sum of square of y, sum of square of x, and okay, square root. And if you are knowing what is called this coefficient, r is a coefficient, correlation coefficient, then you can calculate b. Okay, so like this, okay, you can calculate okay, what is called a and b, and after that you are substituting here, you will calculate y. So it is a very simple algebraic model. If we have b a x, you can calculate y, or if we have y b a, you can calculate x. So it's a mathematical model. It's a very simple algebraic model. You know the basic concept and all. So here you can understand this is the least square regression, and this is the formula. So a can be calculated like this, and b can be calculated like this. Okay, x average. So this is a x average. So that is x now, and all this okay calculated, and I can calculate a mean. Okay, so that is a mean, x mean. Similarly, y and y mean. Okay, that is x mean. This is a y mean, and like this you can calculate. Okay, so linear squares regression equation y equal to, and a can be calculated, b can be calculated. Okay, the b equal to this one. So how it is possible to calculate SSX? I have shown in the table. Okay, so here okay, here I give what is called a mathematical model, sum of x squared. So x squared is here, isn't it? Sum of x squared minus sum of x squared by n. For example, this value is a 10, so here that is a 10. So if you are calculating this one, you will get what is called, that is sum of square of x. Similarly here, okay, that is sum of square of y equal to, okay, that is sum of y squared minus sum of y squared by n. Okay, you can calculate. So based on that, for example, one example given, so I have x, I have y. So based on that, I can calculate xy, I can calculate x squared, I can calculate y squared, I can calculate what is called this one, what is called the sum of square of x, I can calculate sum of square of y, I can calculate. N is according to this example 1 2 3 4 5 6. So here n is 6 according to this example, so that you can calculate what is called a, b, and y and r. Then after that, okay, so this is least square regression equation. Then after that, okay, if you wanted to calculate the correlation coefficient in the computation formula, okay, so you have that is one more formula. It is hiding, please wait. Okay, so this is the equations. Okay, you can understand 1 minute. So because it is hiding, okay, now you can see this diagram equation. See here, okay, how possible to calculate r? For example, in this equation I told you, isn't it? So even here also you can see. Okay, here also you can see. For example, okay, if I wanted to calculate r, then how it is possible to calculate r? Okay, so that is r, I told you, regression correlation coefficient. So correlation coefficient equal to, okay, so that is SPXY. What is XP? Sum of product of XY. Sum of product of XY by sum of squares of x Sum of squares of y, this is square root, you know very well. What is sum of product of xy? So you know very well. See here, okay, that is xy you have. So xy you can calculate, xy you can calculate. Okay, this is the product. Okay, then all the product we are sum. Okay, that is a sum of, okay, what is called product of xy. So this value, and like this you can calculate a, you can calculate b, you can calculate r, okay, and like this. So with this you can calculate, okay, that is correlation coefficient. If you wanted a correlation coefficient for calculation, this is the formula. If you wanted to calculate sum of product of xy, we have formula. Okay, and like this, okay, we have what is called a mathematical model, and okay, you can calculate, okay, whatever you wanted. Only thing is I wanted x and y value. If, okay, even x and y also I can calculate if you have b and a and r. So you can understand. So this is a very simple concept. Based on that, I would like to give you one numerical method, numerical problem, okay, to solve. It's application level. It is very simple. Now you understood, okay, what is a least squares regression line and how to determine the least squares regression equation. So okay, for this first question, okay, you wanted to give the answer about all the points. What is regression? Okay, from here, okay, you wanted to answer. Okay, so regression line, you wanted to write what is regression line, the placement of line, that prediction errors, and what is called linear squares, no, what is the formula for what is a linear regression, multiple regression, and like this you can give a small input, and then okay, you can explain about all these mathematical model. Okay, so you can explain, okay, what is square of sum of squares of y, sum of squares of x, sum of product of xy, and like this you can calculate everything you wanted to explain, okay, for this first question. Which is the question? This question. Describe least squares regression line and determine the least squares regression equation. Okay, now we studied everything. Then after that we wanted to calculate certain things. Okay, see, read the question. Assume that an r equal to 0.3. So what is a b? What is a r? R is the squared, that is a correlation coefficient. R is the correlation coefficient. So r is equal to 0.30 given. Then after that, describe the relation between, okay, education level, that highest grade completed, and estimated number of hours spent reading each week. So obviously, if a child is, okay, spending much time, okay, every week, obviously the grade will be higher. How to calculate? It's very simple, isn't it? So for example, okay, the question is, okay, relate what is called the grade as well as spending time. We can calculate, okay, so already I have given what is called the formula and all, you can calculate. So determine the least squares equation, okay, for predicting weekly reading time from the education level. Okay, so what is this least square equation for predicting weekly? What's a prediction? For example, this is the prediction. Okay, this is the prediction, and for this prediction, okay, what you wanted, x values here. Okay, so x value is given, isn't it? So you can calculate. For example, how to apply? For example, I am calculating what is called b. Okay, so b I wanted to calculate. I am explaining this question. Determine the least squares equation for predicting weekly reading time from the education level. Okay, so I have what is called weekly. No, I have what is called education level, and for that education level, okay, I wanted to predict what is called weekly reading time. So what are the informations given? See, okay, so education level x, okay, mean given, sum of square x given, then weekly reading time, okay, that is mean given, then sum of square y given. Then after that I wanted to calculate, okay, this one. What is this one? Okay, so this reading time I wanted to calculate. Okay, all other parameters given. Okay, so based on this I can calculate a, and I calculate b, okay, and okay, from x, okay, I can calculate. See here, First I wanted to calculate b. So b equal to, what is the equation? Okay, that is r, square root of sum square of y by sum square of x. So I have r, because r already given. What is that? 0.3. So the 0.3 put here. Then after that is square root of, okay, sum of square y. So sum of square y given. It is called weekly reading time. Sum of square y is given 50. Then sum of square x. What is sum of square x? Okay, so education level. Okay, this one. Sum of square x 25 given. So that 50 by 25. 50 by 25 into 0.3 square root. Okay, 42. Now I calculated b. So that is the regression coefficient calculated. Then after that I want to calculate a. A is what? Okay, that is y mean. What is y? This one, weekly reading time mean, minus b into x mean. X means education level. Okay, x mean. Okay, given. So y minus bx equal to a. So that is, what's y mean? Already given. Y mean is given 8. So 8 minus. Then after that b I calculated. B is 0.42. So 42 into x mean. So x mean is 13 given, 13. So this is y mean minus b already calculated 0.42 and x mean 13, that 13. So I am calculating, so I will get 2.54. Okay, so b calculated, then okay, I can calculate what is called reading time. Okay, because y equal to bx plus a. See here, y equal to, you can calculate. So this, okay, calculated. So condition is, two conditions given. One condition is Faith's education level is 15. So this word is very important one. So that is Faith's, okay, education level is 15. So education level, okay, given, okay, 15. From that predicted reading time. So I wanted to find the reading time. So it is very simple, because okay, so x is the independent variable. The independent variable education level is given, that is education level 15. 15 means x value given, and predicted reading time is asking. That means y value they are asking. So you know a already calculated, you know b already calculated, x value is given, x is the independent variable. According to this example, okay, that is x is the education level, 15 is given. So you calculate, okay, that is b 0.42, and okay, so that is x value given as a 15. So 15 calculated, okay, plus a. So already a value calculated as a 2.54. So that is 8.84. What did you understand? So the Faith's education level is 15 and her predicted reading time is 8.84. Okay, so its unit didn't give, so that it considered as hour. Okay, that's it. Then after that, one more questions. Keegan's education level is 11. What is the predicted reading time? You can calculate according to this example, isn't it? The 11 is x. So x is education level. Okay, so you have a b and x you can given. So if you are calculating, and you can calculate y. So according to this example, y is a predicted reading time. You can calculate, but I calculated. Okay, so this one. Okay, so from this, okay, least square equation predicting weekly reading. That means what are the parameters I calculated? Okay, so that is a already calculated, b calculated, r calculated, and okay, I am ready. Okay, r is given. So a and b calculated. Then after that, for the b questions, okay, this one, what is that? Predicted reading time calculated, predicted reading time of Faith, and this is the predicted reading time of Keegan's. So university examination, okay, they may give, instead of 15, they may give different value. At that time also we can calculate, because only what is called as substituting values. But please understand, okay, for calculating this one, okay, you wanted to calculate a and b. Okay, in this example, okay, that is a correlation, r value is given as a 0.3. Sometimes, okay, the people may ask, okay, to calculate r also. For example, okay, they can give SSY, they can give SSX, and they can give B value, so that you can calculate R. So mathematical algebra only, no? So you can understand. So this is the answer for this question. Okay, I hope you understood. If you have any doubt, okay, stop this video, discuss with your group members and understand. Okay, if wanted, again watch this video for understanding the concept very clearly. Okay, this over. So this is a least square regression line, and based on that a small prediction. Prediction is very simple. Whether you wanted to predict what is called different value, okay, from this independent value, and okay, B and A you can calculate. Okay. Next question is, okay, how to calculate standard error of estimations. This is a very important one. Previously we calculated what is called least square values. Okay. Now we wanted to calculate standard error of estimation. So what is the formula? It is very simple. Okay. So standard error of estimation, okay, that is a formula is this one. It is a computation formula. You can use, okay, this one. What is that? Okay, that is a standard error of estimation of Y with respect to X. Please understand. So I already told you, okay, please understand. I already told you, okay, X is the independent variable. From that I am calculating different value Y. Okay, so with respect to X, okay, I am calculating Y. That means Y is the dependent on X. So please don't forget, based on that you solve the problem. Standard error of estimation is, that means standard error of Y value only we are predicting with respect to X. With respect to X is square root of, okay, SSY. You know very well what is this? Sum of squares of Y, and then 1 minus R squared. So you know very well what is R, correlation coefficient, squared correlation coefficient. R value is given as 0.3, don't forget, by n minus 2. Okay, n is how many values? People will tell. Okay, people will tell. According to this problem, okay, so n value is given as 35. See here, n is 35 they have given. So you know n value, then you have R value, okay, you have SSY. So SSY value given, so that you can calculate what is called standard error of estimation. This is a very, very important one, a very simple calculation, but for this, okay, you will get, okay, that is a 10 mark, 8 mark, it depends upon the question paper setup. Okay, so how it is possible? Okay, calculate the standard error of estimate, assuming that the correlation is 0.3 and based on n equal to 35. So apply these values in this equation and you will get it. Okay, so A, okay, that is I calculated, so that is standard error is 1.17. So I applied, for example, SSY is 50, so 50 into 1 minus R squared, so 1 minus R is 0.3, so 0.3 squared by, see here, n is 35, so 35 minus 2. The formula is like this, 35 minus 2. So if you are substituting, you will get 1.17. What did you understand? Calculate standard error of estimation. The standard error of estimation is 1.17. What is the meaning of that? So there is a error. Okay, the standard error is predicted, we interpreted, we predicted, there is a error. How much? Okay, that is 1.17. If error is less than 0.2, okay, we can consider no error, but it is beyond 1, okay, so that is 1% here, so there is a error. Okay, supply a rough interpretation of the standard error of estimations. Here no calculation. What's your interpretation of the standard error of estimation? There is a error. Okay, so error, okay, noticed, and error wanted to minimize. That is a very important one. Okay, so you can understand. Okay, so that is first this is calculated 1.17. Based on this value, I am giving comment on this That means for the second question is, okay, based on this value I interpreted, okay, error, okay, estimated, and error is noticeable one, error is considered one, so wanted to correct it. If the values after calculation, if I get 0.2, 0.1, so then at that time I can give interpretation that error can be ignored. Error can be ignored. So depends upon this value you wanted to give the comment. So university question paper setter can ask, okay, your understanding level, okay, your what is called analysis level. Depends upon this value you wanted to give, okay, your own explanation, your own prediction, your own comment. Okay, now, okay, you understood how to solve this problem, understand? So this value and all given, and you calculated error standard of estimations, and based on that you have given a comment. Okay, I didn't give the comment here, but the answer for this one, B question, supply a rough interpretation of standard of error estimates means what type of your input interpretation? Okay, we predicted, okay, there is a standard error, so that error wanted to minimize. If you are not minimizing, your prediction may not be correct. That means classification accuracy, prediction accuracy will happen. Okay, this is the second question. And then, okay, the third question, it's a very simple. Okay, so what is called least square regression line, and I would like to demonstrate squared correlation coefficient. R squared is squared correlation coefficient. What is squared correlation coefficient? Okay, before solving this problem, I would like to give you small input. Squared correlation coefficient R squared, there is a prediction, like for example logarithmic table you know very well, anti-logarithmic table values you know very well. Like this, the correlation coefficient, squared correlation coefficient values and all tabulated according to Gohen's guidelines, and from the guidelines it is predicted that, okay, if R squared value, okay, this is R squared value, okay, so this is R squared value, okay, this is the R squared. So this R squared value is predicted as, okay, 0.01. That means 1% error means that weak. That means, okay, very low relations. That means no correlation. If, okay, R squared value is 0.09, that means 9%, please notice that relationship is moderate. It seems to be matching. Okay, and okay, R squared is what is called 0.25 level. It is the interpretation is a strong relationship. So 3 range. For example, okay, 0, 1, 2, you can fix up to that is 0 and 7. Okay, it seems, okay, weak relationship. Okay, the 0.9, okay, and associated or in a range of 0.09, that means 9%, then it is a moderate. Then, okay, nearer to 0.25, the R squared value is nearer to 0.25, it is a strong relationship. And one more information is that if R squared value is more than 0.25, what will happen? Okay, it are most unlikely, okay, no relation. That means any table you are giving, and if you are calculating R squared, okay, the R squared value won't come above 0.25. Understand? If value is coming, it seems, okay, the calculation error. That's the reason why given most unlikely. This was predicted by Gohen's, and Gohen's given what is called guideline, table values given. So please remember this one. This is a very important one. Based on this input, try to solve this problem. Okay. So assume that an R is a 0.30, describes the relationship between education level and estimated hours spent. Okay, that and all you know very well. According to R squared, what percentage of variably in weekly reading time is predictable from its relationship with education level. Okay, according to R squared, what percentage of variability in weekly reading time is predicted? Okay, that calculations, okay, R squared calculations, okay, also given. R squared equal to SSY, that is sum of squares of y minus sum of squares of y. Okay, this is called error calculation, you know very well, by sum of squares of what is called y. Okay, this you can calculate. Okay, so from this, okay, so here, okay, R squared, what percentage of variability in weekly reading time is predictable? When can you predictable? When can you tell, okay, there is a association, there is a relationship minimum, okay, that is a 0.09, that means a 9%. So according to R squared, what percentage of variability in weekly reading time is required? So that is a 9%. Understand the meaning? Okay. So the question is, what percentage of variability in weekly reading time is not predictable? Then around what is called 0.1, that is called 1%. You can understand. For this question, what is the answer? 9%. Why? According to R squared, if 9% means, okay, the percentage of variability in weekly reading time is predictable from its relationship. Okay. And the next question, what percentage of variability in weekly reading time is not predictable? The question is very important one. What percentage of variability in weekly reading time is not predictable? What predictable? 9%, isn't it? Because of that predictable, the 9%, okay, not predictable level is 91%. Understand me? 100 minus 9 is 91. For example, okay, I trust this system 80%. What is the meaning of that? I am not trusting that system 20%. You can understand. This is a very important one. So, for example, weather predictions. The weather predictions, okay, the expert telling 90% it may rain. 90% it may rain this night. What is the meaning of that? 90% may rain. 10% may not rain. So that is the message. So the second question is, what percentage of variability in weekly reading time is not predictable? Not predictable means the previous question predictable is 9%. So not predictable is 91%. That means, okay, 100 minus 9. You can understand. Okay. Third question is, someone claims that 9% of each person's estimated reading time is predictable from the relationship. What is wrong with this claim? Okay, whether it is wrong or not, okay, so I suggested predictable chance is 9%. So the answer is like this. 9% refers to the variability of all estimated reading. Am I correct? So 9% means not each person's, every person's estimated. So this is the answer. What is wrong with this claim? No wrong. What is the estimation? 9%, okay, of all people can trust will be predictable. Understand? Okay, the answer. So the problem is applying your common sense and you can answer. You wanted to answer. So no calculations and all. Already Cohen's guidelines given. Okay, so that is, this is called less predictable. That means no association, 25 strong association. Based on that, okay, you can predict. So you are calculating R squared and what is the value from that you can predict. Okay, that's all. So this is the what is called ideas solution to solve the problems. So my dear students, if you have any doubt, watch this video again and again. You make a group, watch 5 minutes or 10 minutes, stop the video, and what I demonstrated, what I spoke, okay, understand. If you have any doubt, discuss with your group members and understand the concept, then you can watch the videos. Still, if you have any problems, okay, you can call me for understanding what is called the concept if you have any doubt. Thank you very much for watching these videos. My dear students, this is a very important concept, regression analysis. It is helping to predict the future. Very, very important concept. So please watch the video again and again. Watch the video to understand the concept very clearly. Then apply this concept to any one of the data set, and you yourself can predict the future. Thank you very much for watching these videos. Bye.